Hi everyone, in today's video we're going to continue our work with solving differential equations using the separation of variables. So the process we've been using so far to solve differential equations is going to remain the same. We're just going to be working with more complex functions that are going to require us to integrate on both sides of the equal sign. So in terms of a basic process that we've been using, here's what we're always going to do when we're solving differential equations using separation of variables. So the first thing, just like it sounds, is we're going to separate the variables. Then we're going to integrate both sides. We're going to write the plus c on one side only, just like we have been so far. We're going to solve for c if we have an initial value, and then really the new step here is going to be solving for y. So these are going to require really kind of extra chunk of algebra to get to our final solution. So let's go ahead and jump in and look at an example. So here we have suppose dy dx is 3xy. You'll notice now the difference is I have x's and y's on the right side. So now in addition to moving the dx over, I'm going to have to move over my y as well. So first we're going to find the general solution, and then we're going to find the particular solution using this initial condition. So I'm going to go ahead first and just copy this down to give myself some room. So dy dx equals 3xy. So the first thing we said we had to do was to separate our variables. So I know I'm going to need to multiply by dx, but I also need to divide by y over here to get rid of this. So I'm going to take dy over y, again, so I can move the y over, and then I have equals 3x, and I'm going to multiply by the dx. So now everything with a y in it is on the left side, and everything with an x is on the right. Now, I'm going to rewrite this just so it's a little more clear. This is the same as 1 over y dy, and here I have 3x dx. And now I know I need to integrate both sides. Again, the difference here is now I have a function of y, so I have to find the antiderivative on that left side. If my derivative is 1 over y, I know my antiderivative is going to be the natural log of the absolute value of y. And that's going to be, let's see, my antiderivative here is going to be 3 halves x squared plus c. Now, first it says to find the general solution of the differential equation and then find the particular solution. Now, I'm going to just go ahead and find the particular solution, and the reason is because I always like plugging in my initial condition at this stage of the problem. So what I'm going to do is I'm going to go ahead and plug in my initial condition here. My x is 2 and my y is 1. So I'm going to have the natural log, the absolute value of 1 is just 1, equals 3 halves times my x is 2, quantity squared, plus c. Now I know that the natural log of 1 is just 0 because e to the 0 gives me 1. So 0 equals, this is going to be 6 plus c, and then I have c equals negative 6. So now I can go ahead and plug in my c, my value of c. I'm going to move the camera a bit here. Okay, so now what we have is the natural log of the absolute value of y equals 3 halves x squared, and I have plus c, but my c is a negative, so I'm going to have minus 6. So now here's where we're at. We've done steps 1 through 4, but now we need to do step 5, which is getting y by itself. Remember, our answer should look like y equals, and so we're not quite there yet. So in the algebra prep, we talked about this. If I want to get rid of the natural log, I have to take e to the natural log of the absolute value of y is going to be equal to e to the right side. 3 halves x squared minus 6. Now I know that e to the natural log of the absolute value of y, that just leaves me with the absolute value of y. This side hasn't changed. Now, I'm going to kind of go over here. in order to be able to drop the absolute value, I know then that y is either equal to plus or minus e to the 3/2 x squared minus 6. And now I have to make a decision. I need to decide whether I should keep the plus or the negative sign. And here we're going to use our initial condition to determine the sign. So in other words, in order to determine whether this should be positive or negative. So here's what I mean by that. If I look back at my initial condition, I would expect that if I plugged in 2 for x, this function should return a y value of 1. So let's see. If I plug in 2 for x, I'm going to get 2 squared is 4 times 3/2 gives me 6. So 6 minus 6 is 0. And e to the 0 should give me a positive 1. Since I want this to be positive e to the 0, I'm going to make the sign of my answer just the positive choice. E to the 3/2 x squared minus 6. And again, that decision comes from plugging in the initial point and making sure you get the correct y value out. All right, let's go ahead and look at another example. We'll go on to number 2. So now let's see what we have here. dy dx equals x squared over y. And again, we're finding the particular solution if we have this initial condition. So my first step is going to be to separate the variables. This one's pretty straightforward. I can multiply by y. So I'm going to get y dy. And on the right side, I'm going to have x squared and then multiply by dx. So all my y's are on one side, my x's are on the other. Once I've done that, I'm going to integrate both sides. Here, my antiderivative is y squared over 2. On the right side, I have x cubed over 3 plus c. And again, I forgot to mention it on number 1, but we're only putting the plus c on one side of the equal sign. So now I'm going to go ahead and solve for c. And let's see what we get. I'm going to have my y is negative 1. So I have negative 1 squared over 2 equals, my x is 1, so 1 cubed over 3 plus c. So I'm going to get 1/2 equals 1/3 plus c. That means c is equal to 1/2 minus 1/3, which is really 3/6 minus 2/6, or 1/6. So now I have y squared over 2 equals x cubed over 3. Let's see, that was a positive, so plus 1/6. So now, again, I've got my plus c. My goal is to get y all by itself. So let's go ahead. The first thing we're going to do is multiply by 2. And remember, when we do that, we have to multiply the whole right side by 2. So we're going to end up really distributing that. So I'm going to get 2x cubed over 3 plus 2/6, or really what I have is 2x cubed over 3 plus 1/3, and I like to make it a common denominator, so 2x cubed plus 1 all over 3. Now that's still equal to y squared. Sorry, I'm drawing all these crazy arrows. I'm going to go over here now. So I know y squared is equal to this. So then if I take the square root, I have y is going to be, and again I have to consider positive or negative, 2x cubed plus 1 over 3. And again, I need to use my initial condition to decide, should it be positive or negative? So let's find our x value is 1. So if I plug in 1, I'm going to get 2 plus 1 is 3. 3 over 3 is 1. And I want the square root, I want the negative 1. So I need to take the opposite of the square root to get that negative out. Again, if I left it positive, I would have the square root of 1, which would just give me a positive 1. So I need the negative out front to get that negative y value. So I have the opposite of the square root of 2x cubed plus 1 all over 3, and there's my original function. All right, we'll go through one more and then we'll save one for when we're back in class. Now 3 is an interesting one because there's a little bit of a trick here. When I look at first, dy dx equals e to the x plus y. At first it's hard to see how I'm going to separate my x and y because they're all kind of tangled up in this exponent. So here's where, before we can separate anything, we're going to have to use our rules of exponents, and what I need to realize is e to the x plus y is the same thing as e to the x times e to the y. So first I need to rewrite that using my exponent rules, and now I can more easily separate my variables. So I'm going to divide this side by e to the y, so I'm going to get dy over e to the y, and that's going to be equal to this e to the x is going to stay. I'm going to multiply by dx. Now to help me out a little before I integrate here, I'm going to rewrite this as e to the negative y. I can bring it up by changing the sign of the exponent. So e to the negative y dy equals e to the x dx, and I'm going to integrate both sides. Now here, we have to be careful with this negative y. It might be tempting to say that the antiderivative is e to the negative y, but we have to be careful because technically there's chain rule here, and I have an extra negative. So my antiderivative is actually going to be negative e to the negative y. And again, that's something I'm able to manipulate in my head. We could have also done a u substitution, making our u equal to negative y. But for now, we're just going to leave it here. Negative e to the negative y is going to be on my right side. I have e to the x and plus c. So now we're going to solve for c using our initial condition. I have, let's see, negative e to the opposite of the negative natural log of 2. That's going to make it positive natural log 2 equals e to the 0 plus c. Now, e to the natural log of 2 is just going to be 2, so I get negative 2 equals 1 plus c, and c is equal to negative 3. So I'm going to bring my work up here. Now I have the opposite of e to the negative y equals e to the x minus 3. First thing I'm going to do is get rid of this negative. So I'm going to multiply everything by a negative 1. So I have e to the negative y equals negative e to the x plus 3. To get this negative y out of the exponent, I'm going to take the natural log of both sides. I'm just going to write this as 3 minus e to the x. Now the natural log of e to the negative y is just negative y. This side is going to stay the same. And then dividing by negative 1, I get y is equal to opposite natural log of 3 minus e to the x. Now here, we didn't need to use the initial condition to determine the sign. However, I will use it to check that my answer makes sense. So if I plug in these values, I should get the correct answer. So let's try with plugging in x is 0. If I make x 0, I have e to the 0 is 1, 3 minus 1 is 2, and my y value is negative natural log of 2, which is what I expected. And so that tells me that my answer is reasonable. Now, I know this was a relatively short video, but there's a lot in here, so please, I would recommend going back and watching any parts again that you had questions about. We'll talk about number 4 in class to make sure everyone's got this process down. All right, thank you, and see you back in class.